Good morning. Good morning. Here, for this class, we have to discuss about the problems on radial distribution system, ring systems, and interconnected system. In this one, we have the parameters of I. We have to calculate the parameter. What is the parameter current I and power loss, active power and reactive power, and line to line voltages and phase voltages we have to calculate. Okay, line to line voltage and phase voltage. What is line to line voltage? What is line to line voltage means R, Y, B and neutral supply. Okay, this is R, supply R, this is Y, this is V, this is neutral supply. So V, voltage V, R, N, this is the phase voltage. V, R, Y, this is the line to line voltage. Okay, so here we have to calculate line to line voltages. This is nothing but this one, line to line voltage VRY, and line to neutral voltage, line to RN, VRN. Okay, that is phase voltage. We have to calculate these also. So here, for that, we want to know the basic formulas. This is a line have some length. This is point VS, this is point VR, impedance Z, current I. So here VS equal to VR plus I into Z, line impedance, line current and receiving end voltage. This represents the loss, nothing but voltage drop with respect to this impedance. If you want to calculate for phase R, simply we put IR and ZR. If you want to calculate for Y phase, Y, IY, this IB, IZ. Okay, that much we have to calculate. Here another formula is there, that is power P equal to VI cos phi, VA cos phi. So VA cos phi, this is the line to line voltage. V is nothing but line to line voltage. I is nothing but phase current. This is power factor. Okay, first model problem. In some problems they given a three phase line for the three phase line radial system. In some cases they given line to line voltages and phase impedances they given R, Y, B, phase impedances they given. In that condition, they want to find out the line to neutral voltage, In some cases they want to find out the load angle. Here you have to observe cos phi. This phi is nothing but, this is power factor. This is power factor angle. Load angle is nothing but delta. Okay, load angle is nothing but delta. So this is the power factor angle constant, this is the power factor angle phi, this is the load angle delta. You need to calculate this one. What is that? In some problems they give three-phase power, three-phase line. For that you have to find out line, they given line to line voltages and line what is called phase impedances. You have to find out the line to neutral voltages and load angles. This is the one type of problem they ask. Okay, for that we need what do you need? They given line to line voltage, they given impedances. Now we have to find out, and they given load also, load value L also they given, you have to find out, and the given cos phi also. So now what is the given data? This is the given data, VLL they given, Z they given, cos phi they given, and load power, load they given. Okay, these four parameters are they given. We have to find out VLN and load angle. We have to find out these two. For that we need the formulas, some formulas. VL equal to V line equal to root 3 V phase. This is a basic formula, all of you know. Now V phase with respect to the phase voltage, VLL by root 3. From that we can get the phase voltage. Now we have to use the formula Vs equal to VR plus IZ. So this is the sending end voltage, this is the receiving end voltage, we all know. From that you can get root 3 equal to V line to line IR cos phi. So with respect to the voltage, formula will change, IR cos phi R. So if you want to calculate IR equal to P by to power by root 3 VLL cos phi R for that one. So here from all these we find out IR value, and cos phi value already we know from the given data. Cos phi value from the given data. From that we can find sin phi r also. So we all know that if you cos theta value is 0.9 for example, so that will goes to phi equal to cos inverse of 0.9. okay, 0.9. So this is sin phi r, we have to find out. Okay, now we know the receiving end current IR, sending end voltage, and at the same time we have to find out V phase equal to VR plus IR ZR. So already phase voltage they given, okay, phase impedance they given. We calculate the V phase voltage from the V line voltage, and we just calculate IR value, and so we have to calculate this value, receiving end voltage. Now receiving end voltage is nothing but VR is nothing but receiving end voltage, that is nothing but V, whatever may be the phase, VRN. So we will find out VRN. This is the model problem 1. So I have to calculate briefly I have to give in the total. In some problems, in first model of problems, 3-phase system they are given, line to line voltage they given, ZR they given, means Z means phase voltage they given. If you want to calculate R, if you want to calculate Y, if you want to calculate B, the phase for respective phase impedance they given. So now from the given data, we have to calculate line to neutral voltage and load angle. So this is load angle phi. Okay. So from the given data, this is given data. From the given data, VLL they given line voltages, Z they given, cos phi you have to find out, load value they given. Okay. You have to find out the phase voltage and the load angle, line to neutral voltage and load angle. So here, so we know the basic formula, VL equal to root 3 V phase. So from that we can get a V phase value. That is the part 1. Now part 2 of the problem, Vs equal to VR IZ. So here Vs we know, Vs we know, we don't know the what is the VR. Z we know, and this I value also we don't know, right? First, so we have to calculate this I. So for that I have used this formula, P equal to root 3 V line to line voltage into I current cos phi. Now I am applying for the phase, first phase R phase, IR equal to P by root 3 VLL cos phi R. So from that we can get IR value. So here from the given data, cos power factor will be given. So from that I will get sine value. So these IR equal, now we know the formula, V phase equal to sending end voltage equal to receiving end voltage plus IR ZR for R phase. So from that we will get from the given data we will calculate V phase and ZR we calculate. Just now we calculate IR. Now we have to find out VR value. So that VR equal to line to neutral voltages. From this equation, polar coordinate, Cartesian coordinate to polar coordinate, when you translate these two, we will get the delta value also.